Okay, so today we're talking about independent and dependent events. Okay, so before we do that, we need to know that everything we're doing today is theoretical probability. It's a probability defined as the number of favorable outcomes divided by the total possible outcomes. So what that means is just what we did on our last probability lesson. The number that we want over the total options that we have. Okay, so for this one, find the probability of selecting a red marble. So the first thing I always do is figure out how many marbles I have. Well, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 marbles. I'm going to try this. It's not going to look pretty. So 9 marbles. 9 would be the bottom of my fraction. How many of them are red? 3 of them. I always like to simplify if I can. So my probability would just be 1/3. Okay? And that's the theoretical probability. All right, so here's the common mistake that a lot of people make. They say the answer to this question is also 1/3. What is the probability that the second marble will be red? Well, it's not 1/3 because if I take a red marble out and then I go to draw for a second one, everything has changed. Okay, so you can see that here. I now only have 8 marbles instead of 9, and I actually only have 2 red marbles, so 2/8. My probability would actually be 1/4. Okay, it's gotten even smaller because my chances are smaller. That is something that we call a dependent event. It's dependent because your numbers change. Okay, if I drew a red marble, then that's going to affect what I draw the second time because my numbers are different. Okay, the opposite of a dependent event is called an independent event. So flipping coins is an independent event because if I flip a coin, I could get heads or tails every single time, no matter what I got the first time or the second time. So this is an example of an independent one. Jason tosses a coin 10 times and gets 8 heads. What's the probability that he will get heads on his next toss? Well, 1/2, right? Because there's only 2 sides, only one of them is heads. I could change this question and say, what's the probability that he will get tails on his next toss? And my answer is still going to be 1/2, because nothing changes. It's always 1/2. However, on this example, you select a blue marble from a bag and do not replace it. So now I'm out this blue marble. It's no longer there. What's the probability of the second marble you'll pick? Well, now I have 7 marbles, and they want my second one to be green, so that leaves 3 greens. Okay, that's my probability. This one was dependent because my number on the bottom changed to 7 because I had to take one away. Sorry. Okay, so you don't get to do the practice, but so an example of an independent event. Rolling a dice and spinning a spinner. Okay, it doesn't matter what number I roll on the dice to what I spin on the spinner. Those would be independent. Dependent would be drawing a card out of a deck and not replacing it. Okay, because that then determines what I'm going to draw the next time that I go. Fill in the blanks. We're going to kind of skip that since you can't do that. Just a reminder, theoretical probability is defined as the number of favorable outcomes divided by the total possible outcomes. Independent events are ones that are not affected by previous events or events that follow, and dependent events are affected by previous events or events that follow. Okay, so we're going to skip that one. We're going to go to this one. We're going to change up the question a little bit. What is the probability? Let me just pull this up here. Okay, we want to know what the probability is of him getting a red paperclip and then him getting a blue paperclip. Okay, so I first go with my red one, There are 49 paper clips, so 49 is going to be my number on the bottom. There are 9 red. So that's my first pick, my probability that I'm actually going to get a red one out of the bag or box. Now, I also have a second pick because they said after that, I don't replace it. I'm going to draw a blue one. Well, there's 6 blues, so 6 would go on top. But I did not replace this one, whatever it was that I drew. So now instead of 49, I have 48. Okay, now it's not asking me for 2 separate probabilities. It's just saying, what would my probability be for 1? So you have to take these 2 fractions and you have to multiply them. So, back out of here. Probability of red, and then the second one is blue. This is my red probability. This is my blue probability. If you multiply those, and you want an actual calculator so you can use the fraction button, you're going to get a ridiculous fraction that equals 9 over 392. Okay, and that is your actual probability that you're going to pick a red one first and then a blue one. So pretty dang low. You always just multiply your 2 probabilities together. Okay, so let's do this one. What's the probability that Andre chooses a bag of potato chips and then a bag of pretzels? Let's see what we got going on here. He has got 5 bags of potato, 4 bags of pretzels, and 1 bag of corn chips. So that gives me 10 bags. The first one they want him to pick is a bag of potato chips. So that would be 5 out of 10. And then a bag of pretzels. So 4 bags of pretzels are left, but he has already picked a bag of potato chips. So now I don't have 10 bags, I have 9 bags. And I multiply those together. So 5 out of 10 times 4 out of 9 gives me 2 9s. Bam. Okay. Let's do one more. This one. This is independent because I am flipping heads on a coin and rolling an even number on a number cube. That's just a fancy word for a die. So if I flip heads, my probability for that one's just 1/2. A number cube has 6 sides, and 2, 3, and 4 are even if I roll those. So that would be 3 sides that are even. And then I just multiply those 2 together. See how these 2 fractions really had nothing to do with each other? This was coins, this was a dice. They didn't have to subtract anything because they didn't really apply to each other. So really I'm taking 1/2 times 1/2, which is 1/4. Okay, and that is what your lesson's on today. So go ahead and go to Go Formative. Let me kind of help you out with the... I did not think this through. I should already have this pulled up. Sorry. The way they write the questions on here have freaked people out today. So I want to make sure you are confident in what you're doing. 7th grade, probability, independent and dependent. Okay, so this one right here, this says we're rolling a number cube and we're spinning the spinner right here. So what's the probability of us rolling a 1 and spinning an A? So I'll kind of help you out with this one real quick. If we roll a 1, well, I know a number cube has 6 sides. Only one of them is a 1. Okay, and then if I spin an A, well, there's 4 sections on that spinner. Only one of them is an A. So you're just going to multiply those 2 together to get your answer. All right, that is it.